Okay, great. There we go. All right, so welcome everybody to Growing Up, Designing with Mass Timber. If you're joining us from the last session within this kind of embodied carbon track, you just heard about procuring climate smart forest products. So in this session, we're going to take this one step further and hear from our experts on how to design and build with mass timber and the innovations occurring within structural mass timber products. So the learning for this objectives are shown here, and we'll be following up with a survey and with more information on how to receive credit from AIA. We'll also be collecting all the questions submitted during the session, and if we don't get to it at the end of the Q&A, we'll have our two speakers answer that, and we'll post that later to the CarbonPositive website. And with that, it is my pleasure to introduce our two speakers in this session. I'll keep their introductions brief so we have time for content and Q&A, but you can read their full bios on the CarbonPositive website. So our first speaker will be Julian Anderson, director at Bates Smart. Julian has worked on a number of significant projects, both in Australia and overseas. His broad sector experience incorporates commercial, residential, hospitality, infrastructure, and urban design projects. Following Julian, we'll hear from Ben Kaiser, owner of Kaiser and Path. Ben brings a unique perspective to urban development, informed by over 20 years of serving as the owner, developer, architect, and general contractor on his projects. He is committed to mass timber construction, and his firm has designed and built the tallest CLT structure in the United States, Carbon 12. He and his partner in the company are co-authors for the Mass Timber State of Industry annual report as well. So with that, I will go ahead and hand it over to Julian.
Thank you very much, Lindsay. I will share my screen. There, okay, there we go.
Yep, great.
Okay, thanks, Lindsay. And look, thanks for the opportunity to speak at the forum. As Lindsay mentioned, I'm a director at Bates Smart. We're a practice which was established in Melbourne 165 years ago, and we now have offices in Sydney and Melbourne with about 300 people across both those offices, and we work across multiple sectors. So the projects I'd like to talk to you about today, primarily 55 South Bank Boulevard, which is currently is now an Adina hotel. It was developed by Hume Property Group, and we thank them for the opportunity to be involved in such a rewarding project. It's a 10-storey timber extension and primarily uses cross-laminated timber and glulam. One of the great benefits, as I'm sure you're aware of cross-laminated timber, it's time-saving on site due to large amounts of off-site manufacture, but this does mean that there is a need for greater time pre-construction for the coordination of the design, because all of the openings, including the service openings, are cut in the factory. And as you may be aware, one of the great things about cross-laminated timber is the fact that it is 20% the weight of concrete. Unfortunately, the most energy consuming aspect of cross-laminated timber often is its transportation, since so much of it is manufactured in Europe and Scandinavia. And in the case of 55 South Bank Boulevard, our timber was sourced from KLH in Austria. So the predominant material in the extension is cross-laminated timber, but we do also use glue-laminated timber, where layers of timber are cut in the same grain and jointed and glued together. This gives the glulam product strength in a direction, and it's for this reason that glulam is predominantly used for beams and columns. So our site is shown here in red. It's in a suburb in Melbourne called South Bank. It's on the south side of the Yarra River, which you can see running through the centre of the image, and to the north of the Yarra is our central business district. The existing building, which you can see on the right here, was built in 1989, and it is a concrete framed structure. It's a 6-storey building comprising about 7,000 square metres of net commercial space with some car parking at the rear. And the additional structure was designed to take 5 or 6 levels of new concrete structure over, but using cross-laminated timber, we were able to deliver 10 levels of new structure, which has allowed us to deliver 220 hotel rooms, which is the optimum number of rooms for a a hotel development of this type. So this is now one of the largest timber adaptive reuse projects in the world, delivering 13,000 square metres of new floor space. And then our local context, you can see our small building here. It is somewhat dwarfed by a range of other towers in the area, and this suburb in Melbourne is forecast to become the most populous suburb in Melbourne by 2035. And then if I take you to, this is a floor plan of the existing commercial building. And you can see what we did was we replaced all of the existing mechanical systems, which this building had a floor by floor mechanical system. And in this location here, we put the new lift core, which connected our ground level lobby with our 10 levels of new hotel rooms above. And then similarly, you can see at the base of the plan here, our existing fire stair in the commercial building. In our new building, our new extension, we located the new fire stair in that orange zone there, which then allowed us to take run all of our egress paths through to tie up to that existing fire stair. So quite a subtle intervention into the existing commercial floor plate. And it did mean that, interestingly, this commercial building, the existing 6 levels were allowed to continue operation during construction, which we think is a pretty significant achievement. I'd then like to show you this animation. You can see here, this is the existing building. We built a new level of office on top of the existing building. Then we had a significant steel transfer floor. On the left in here, you can see our new lift core in steel. On the right, our new stair. And then we had 10 levels of cross-laminated timber, levels 8 to 17, all of which are the same. So in terms of design and construction efficiency, it was a highly efficient outcome. And then that is wrapped in a high-performance double-glazed unit facade system. Our overall section, you can see here in orange, the 10 levels of new hotel accommodation sitting on top of that steel transfer floor at the transfer floor, and I'll show you a plan in a second. We located our pool and gym area, plus also the new plant for our new building and the existing relocated plant from the office building below. This is a detailed section here. You can see the relationship of that new office level sitting on top of the existing office below, and then the pool deck area, and then the hotel above. The typical floor build-up is 165 millimetres of cross-laminated timber with fire-rated plasterboard to the underside. And importantly, all of the cross-laminated timber used in this building is clad in plasterboard or drywall for fire protection reasons. And the typical floor finish is carpet laid on 19mm lightweight cement composite board. This is an image of our original design, early design thinking. You can see here that we have a recess here, which allows us to articulate the extension of the building, and the recess is the level at which we delivered that new office. The floor by floor banding in the new hotel rooms references the incorporation of the horizontal banding in the existing. So a highly contextual response to the existing condition. On the corner of the building where the building turns the corner, we have this highlight moment, which is a celebration point in the building where we have a balcony, a curvilinear balcony, which occurs at the amenities level, and the balcony's gently curved opening provides an outdoor space which is accessible via the gym. This is a perspective section showing the relationship of our double glazed curtain wall facade to our timber floors. An image, well actually a render, this is now complete, but this is a render of our ground floor lobby. You can see here we have reception space and a cafe. It's all lined in timber, highlighting the presence of the new hotel above and connecting the ground floor space to this extension. The timber used is an American oak batten, and the curved walls in the lobby space respond to the curved facade above and the sinuous lines of the new extension. It's a ground floor plan showing retention of the majority of the existing structure, shown here in grey. From a sustainability perspective, that was very important to us, and you can see the very minor, I guess, addition of this new accommodation in the form of a lobby, which provides access to our primary entry point on City Road, with offices and back of house spaces. And this is the location of our new lift core here, which runs through the building and connects up to our 10 levels of hotel accommodation above. This is a detail of our lobby space, showing very well lit north facing lounge space. It's a double height lounge space to create some drama. So we have meeting rooms and pre-function lounge space, and a lift to the right at this level. And then if we jump up to level 7, sitting on top of that new office level and the existing office, we've located a swimming pool on the north side of our site, which benefits from great access to natural light, a gymnasium through which you can experience that balcony moment. And then all of the new plant is located at this level, as well as the existing plant. So that allowed us to unlock those existing fan rooms as the location for our new lift servicing hotel rooms. A detail of that pool level with fantastic views back towards the city, and very generously scaled for a hotel of this type. And then the hotel rooms. This is a typical 2-bedroom hotel room. This is on the corner, so it gets that sweeping arc and all those fantastic views. We were very interested in bringing timber into these spaces, albeit the cross-laminated timber was clad. We were, as a result, very keen to introduce timber into the space in the interior design. This is our typical hotel floor plan. So this is the hotel floor plan that's consistent between levels 8 and 17 of the development. And the walls, the cross-laminate, all of these timber walls, interstitial walls and corridor walls, are all timber, cross-laminated timber. They do narrow towards the top of the building. So the CLT panels are 150 millimetres wide at levels 9 to 11. 135 mils at levels 12 to 14, and 105 mils at level 15 to 17. So this has minimised the weight of the cross-laminated timber required for the structure. And there are only 5 room types in total. So in terms of the cross-laminated timber, this is one of those panels that's gone into making up the interstitial walls. There was approximately 5,300 tonnes of cross-laminated timber used. And the CLT will offset about 4,200 tonnes of carbon dioxide from the atmosphere. And all of the timber sourced was supplied by suppliers with Forest Stewardship Council certification. Interestingly, I think the project, if it had been built using concrete precast panels, would have required 5 times the number of panels, and therefore 5 times the number of crane lifts. This is the building under construction, and typically our glazed curtain wall is never more than 1 or 2 levels behind the timber structure, and that's largely in part due to the fact that we don't need to wait for any concrete to cure. That's a view of our pool looking north, a view of the hotel rooms, including one of our bathrooms. We did use bathroom pods, so prefabricated bathroom pods for the majority of the rooms, which has contributed to reductions in material wastage, which is also very important to us. Then a bedroom, and you can see there the timber highlights, although not cross-laminated timber. It does reference the core material used in the building. I did also want to talk briefly about another project which we completed last year, which is our, I should mention there's some overall images of our complete building on the left, and a detail of that balcony detail on the right. I did want to talk briefly about 25 King Street, which is a project we completed with Lend-Lease and Impact Investment Group last year. This is a project that was delivered in Brisbane. It comprises approximately 14,500 square metres of net lettable commercial area. It is the tallest engineered timber office building in Australia, and also holds the title for the largest gross floor area for an engineered timber office building in the world. It was inspired by the Queensland vernacular, the state in which the building is located, and we have an enclosed veranda you can see in the sketch here, which is creates a sheltered colonnade and addressed to the primary street frontage, and brise soleil set within open frames added to the west as solar protection. And the building was located in a part of Brisbane, which had a lot of competition, and essentially that inspired Lendlease's decision to develop a product which was quite different to its competitors, and the decision was made to go with a Glulam structure and cross-laminated timber core. This is the ground plan. You can see a very generous colonnade through here, retail either side with a lobby symmetrically arranged. It is a side core building. So you can see we were very interested in expressing exposing the timber. All of this timber is, however, clad in a material called Oceania, and that's been applied to all of this exposed timber, including the soffits. It's a modified timber product which is highly durable and is guaranteed for 50 years in external conditions. This was the final column layout at 6 by 9 metre column grid. There has been a shift, we think, in office markets to say we don't necessarily need column-free space to have a great space, and the shorter span does help deal with vibration. And the timber columns in this instance are generally about 550 mil square, and you compare that with a traditional, if you were to develop a traditional concrete frame structure, you typically start with 9 by approximately 12 metres. The timber grid is quite different, but we don't think it limits flexibility. And you can see here, this is an example of a test fit. We've also located a void on the south side of the floor plate, which I'll show you an image of the completed product. Unlike 55 South Bank Boulevard, the timber really is expressed externally and internally, and we're very keen to do that in order to announce this building's environmental credentials, and we were eager for it to speak of a more sustainable and environmentally responsible future, and also due to the side core, the stability of the structure was transferred through the diaphragm CLT floor and the braced frames around the perimeter of the structure, which you can see in this elevation. This is a detailed section. Our typical floors are 3.7 metre floor to floor with exposed surfaces, and also importantly exposed cross-laminated timber floor soffits. We know that the comparative fire tests of timber and steel show that a steel I-beam does deflect much more than a timber beam, so that's allowed us to expose all of the timber. We did increase the dimensions of the timber columns in order to allow for charring layer, which is required in order to deliver the requisite fire performance. All of the beams are also exposed, and as I mentioned, there are no ceilings, so we're keeping the cost down in that regard. It also provides a sense of greater connectivity with nature and a warmer, more natural feeling to the interior spaces. And we're seeing that tenants are more and more accepting of exposed soffits, particularly when they look as good as this. This is our lobby, so we were keen to complement the timber by bringing greenery into the space, and then some construction shots. And it really is like it's like a part. It's a giant timber Lego project with a huge amount of accuracy and precision arising from off-site fabrication, and typically not more than about 6 people on site putting these panels in place and columns and beams in place at a time, which contributes to a very clean site, very efficient and very, very safe. This is an image of the internal space, which we're very, very pleased with. I think we've always been interested in exploring this idea of biophilia, which is a term which talks to greater connection with nature, and we're seeing that in many of our buildings. This interest in buildings which can start to investigate ways in which people can improve their connection to nature through light, air, and greenery, and it does lead to improved productivity and a sense of wellness, and it's been well documented that that these sorts of environments can contribute to improvements in people's emotional states, reduced blood pressure, heart rate, stress levels. The improved air quality contributes to reduction in humidity in the environment, and most importantly, it's obviously a fantastic long-term store for carbon. And the engineering firm Orion moved into this building, and we're very quick to post images of their staff hugging these columns on Instagram, which for us is a fantastic validation of everything we've done. And being able to deliver with Lend-Lease on the project. So thank you. Thanks, Lindsay. Thanks, Ben.
Wonderful. Thank you so much, Julian. That was a great presentation. Okay, I'm going to go ahead and hand it over to Ben.
Thank you. Julian, those are great. Those are fantastic projects. Appreciate that. And it's great combination of both a brand new construction as well as the renovation addition. And like you said, it's those products, those mass timber products that allow that to happen. So fantastic. Thank you. Many of you are probably realizing what we're all going through around the world these days. I'm from the northwestern part of the United States, which is presently on fire. It's the largest fires in our history in northwestern United States. We've lost over 5.5 million acres of trees and all the animals and wildlife in those trees. And so that's essentially tantamount to a clear cut of 5.5 million acres of northwestern United States. As well as you can see here, it's the addition of all that carbon back into the atmosphere. So the work that Lindsay and Architecture 2030 is doing, as well as Julian and his firm is doing, we're trying to capture that carbon and pull it back into buildings. And for us as an architectural firm, and as Lindsay mentions, a development firm and a construction firm, that's really the most critical aspect of it, is what we can do worldwide to get a hold of this catastrophic outcome of flooding and seas rising and forests burning. And I think Julian in Australia just went through last year what we're going through this year. So in the Northwest, we no longer have a fire season. We now have climate fires. So they're not even putting a season to our fires anymore. They're year round. So it really is, I think, beyond critical, the steps we're taking as architects and builders and developers and really citizens worldwide to do anything we can. And from our perspective, this is what we can do. And by we have a theory actually that the projects that we put these carbon sequestering buildings on actually have a lower carbon footprint than an empty site, an empty building site. It's a bit of a stretch, but you can kind of start to think the responsibility of the onus on all of us to do what we can. So this is what we're doing. If you wouldn't mind going to the next one, Lindsay. So just briefly, as mentioned, we're a small team, but we're kind of do everything soup to nuts of buying the land all the way through to renting or leasing the property. Thank you. Next one, Lindsay. And we really feel trees are the way to do that. And we're tying ourselves inextricably to the U.S. Forest Service and understanding and learning everything we can about where trees are cut, how they're harvested. As Julian mentioned, FSC certified wood or not. We have a lot of certification systems in the United States, and really trying to understand if what we're doing is really better for the environment and how it's better for the environment. And we're convinced that it is. The next one, please. This is our first project. It was kind of our foray into mass timber. It was about 8 years ago. It's just a Class A office building. It was not using cross-laminated timber. It was only using mass timber, so glued up members. We learned a lot of mistakes we made on this. We learned a lot about staining, about construction, about design. The next one, please, Lindsay. This is part of a 3-building complex, all mass timber. One is all mass timber in the upper left. The 2 other lower ones have a combination of mass timber together with shear walls of steel. The upper left has shear walls of plywood. But again, no CLT in these buildings. And then the next one, please. And then from those buildings, we've moved on to carbon 12, which is the, as Lindsay mentioned, the tallest in the United States right now. And this is where we added cross-laminated timber to the conversation. And this was born out of what's called a nurse log. And a nurse log is a fantastic kind of poetic image of when a tree falls in the forest. It's given about half of its life alive and half of its life dead to give over to the next generation of trees in that forest. So this is a nurse log, a concept that came into this building. The next one, please. And as Julian mentioned, what's fantastic, and this is, I think, along with the carbon sequestering aspects of these buildings, I think what's the most amazing thing, and this is what's going to transform architecture around the world, and this is why it's different than concrete and steel, is because the design process is longer in the beginning, but then once you push order on the flat pack kind of skyscraper idea of this, you have a building that's completely ready to erect. So this is an all wood building that we never used a saw on. We never used a drill on because of all the work done up front. Now you're putting it into place, just clicking together these buildings like as an erector set, as Julian said, which is, I think, impossible in the world of steel and concrete because of the form work and the expansion and contraction of steel and all the other trades involved, whereas wood, just a few people can erect a skyscraper. So much so, and this is from the architectural perspective, so much so that I think it's not long that architects will move the entire line item of the structural package of skyscrapers into their side of the ledger, meaning not on the general contractor side, but on the architect side, because it was the architect who designed the entire thing. So they, I believe, should get that component of the budget on their side of the line item, because they'll be ordering that building delivered straight to the site and bypassing all the general contractors' usual shop drawings and in job trailers, all review of shop drawings and all that. That'll all be done a year or a year and a half beforehand and delivered right to the site and erected. And I think that's pretty transformational, and that's what's going to make the rapid adoption of these materials even quicker, not only based on carbon sequestration, but actually on that aspect of prefabrication in very, very large buildings. Okay, next one, Lindsay, please. This is a floor plan of carbon 12. Next one, please. Again, kind of that prefabricated aspect of it, going right from, and we're days away, I'm not sure about Julian's office, but we're days away with having our BIM modeling, in our office, our BIM models, our 3D models communicate directly with that CNC machine on a factory floor. So you can kind of imagine what that means. I don't think it's far away before an architect pushes a button and orders the building and everything associated with that building. And so you can kind of imagine how that's going to disrupt the world of development when it's the architect ordering the flat pack, whether it's a 6-story building or a 46-story building. I think it's going to be done right from computer speaking with computer and bypassing all of that interstitial stages of shop drawings, which many, many mistakes are made at, and I can attest to that. So next slide, please. Again, some of the click together components of these buildings, which are just amazing. Again, an all wood building, no saws used on site. Thank you. This is a brief video of, I think if you hit play on there, Lindsay, it'll start. And just shows the clicking together of these products. Sometimes it's an intense video, but this was, as Julian said, we had like 4 people erecting this building and doing about a floor every 4 days. It's kind of interesting. You can go to the next one, Lindsay. That's a hard video to load. Thank you. And this is the interior. And also, as Julian mentioned, there's always a struggle in these projects, whether we're allowed to or can't expose the timber. And for us, as for Julian, it's imperative in order to tell the true story and actually get all the biophilic benefits to expose this timber. So we're focused on trying to move ahead with our local jurisdictions on going higher and broader with exposed wood, because we think, and there's plenty of proof from around the world, that these are safe enough without entombing them all in drywall for fire protection. Because a bit of irony on this building is that the steel, the core, the lateral system is steel, and that had to all be protected by drywall, but the wood did not. Okay, Lindsay, if you can go to the next one. Another interior shot, carbon 12, and the next one, please. This is the project we're just finishing up. I think we just got our occupancy permit a couple weeks ago. This is a 6-story all timber multi-family building, and we had some fun in the interior cores with CLT panels zigzagging down an open atrium. And it wasn't intended as this, but it's as a result, it's kind of post-COVID architecture. All the circulation systems are actually outside. So we're thankful for that. We kind of stumbled into that one, but we're also pleased with how, again, CLT clicks together so well. And again, we were doing about a floor every 4 to 5 days. Okay, next one, please. And this, we have on this project Japanese investors. They came to us from Tokyo. They're a large development firm in Japan. And they came to us seeking to learn what we know about mass timber and about cross-laminated timber, because they'd like to bring those learnings back to Japan, for obvious reasons, being the timber history of Japan, and as well as all the environmental benefits and design and erection benefits. So this building has a small alley in the back based on some alleys in Kyoto that we loved very much. And again, these are CLT buildings on both sides. And so a great double loaded alley, again, based on these Japanese retail alleys, which connects this building on the left, which is called the Canyons, to the building on the right, which is called Carbon 12. Thank you, Lindsay. And now we've gotten, as I mentioned, U.S. Forest Service grants to explore taller, better, wider, more safe projects. And so this is called the SPAR. It's about 380 feet. And we're kind of in early pre-development stages of developing this idea in Portland, Oregon. Okay, the next one, please. And we've also made a pledge, and this is spreading around the world, which is kind of exciting, that we're planting the trees equal to the board footage, of course, at maturity, but we're planting the trees prior to occupancy permits on our buildings. So then we have kind of a triple bottom line on that, in the fact that not only have we sequestered carbon in the building, but code in the United States is trees have to be planted when they're cut down. That was instituted about 30 years ago. And then we're taking it upon ourselves to plant those trees again, because we need to make absolutely sure that we're doing the right thing in regard to the environment, regardless of the laws around us. And so this way it's irrefutable that we're aware of where these trees are going and aware that they'll sequester the carbon equal to the trees in our buildings. One more, please, I think. Yeah, and that's the just imagining the future cities made out of these timbers. And then if I can, just for a second, there's I'll just share a website, buildingcarbon12.com, and that gives all sorts of breakdown about how to build these buildings, how to design these buildings, all the benefits of building with these buildings. And it's a very helpful tool that we worked with together with the U.S. Forest Service on making that happen. So that's buildingcarbon12.com, and that's a great asset for learning architects or developers or builders. A lot of budgetary information in there, and so please feel free to visit that when you get a chance. And that's all. Thanks, Lindsay.
Wonderful, thank you. And we'll put a link to that website in the answered Q&A on the CarbonPositive website. So with that, I'll invite Julian back for a bit of Q&A.
Lindsay?
Great. So we've gotten quite a few questions regarding cost comparison of cross-laminated timber to other materials. So one question, how does the price of cross-laminated timber walls compare with gyp walls? So cross-laminated timber with gyp compare to walls of steel and wood studs or brick walls? And the other question on that was just a general, what are the cost considerations when building with CLT compared to concrete and steel?
Well, Ben might be able to provide detail on comparison with sort of traditional construction. But one of the reasons that our developers are proposing use of cross-laminated timber is the speed. So getting in and out of the site more quickly. Unfortunately, in the case of 55 South Bank Boulevard, about halfway through, we got an incredibly wet winter, which did slow us down quite dramatically. But I think, look, I think in the case of 55 South Bank Boulevard, the project just wouldn't have gone ahead with any other construction technology, because the timber allowed us to deliver the 220 hotel rooms, which was the magic number for the hotel operator, Toga, and their Adena Hotel. So in that instance, timber was the only solution. But look, maybe Ben, you probably have more information than I do. Sometimes our developer clients keep their costs pretty close to their chests.
Yeah, and that's a great question, and you're right, Julian. That's what's interesting. Our perspective is because, and you've experienced this, and so have I, that developers don't tell architects the truth. Architects don't tell builders the truth. Builders don't tell the architects or the developers the truth. And not that they're, I think it's just everybody keeps their information pretty tight. So we, since we can see it from all three sides, we started, so the radiator was built at about $175 a square foot. So that's square foot here, of course. And that was mass timber, not CLT. Then we moved to carbon 12, and that was CLT, and we jumped quite a bit higher because it was the first really in the country, and we were learning a lot. So that probably shot up to $325 a foot. First time us using CLT, first time. And now with the canyons, we're back down to about $186 a square foot. And for us, that is equal to just standard stick framing with TJI open joist wood framing 5/1 construction, which is very standard here. And we did a deep dive into that cost comparison because we knew that was going to be critical. And we found for the first time that cross-laminated timber was beating TJI construction because of all the ancillary benefits of exposed wood ceilings in all of our apartments, reduction of drywall throughout the building, lightening up the entire building. So we felt the benefits far outweighed that minor discrepancy in cost. So much so that now we're working on an affordable housing project. And 5, 6, 7 years ago, people were asking me, is it the right material for affordable housing? And I was absolutely not. We all have too much to learn. But in this short time period, it is now applicable to affordable housing projects. In fact, we were just asked by some local folks here, because we've lost many fantastic towns, small towns here in Oregon and Washington and Northern California. And people are going to be rebuilding these, and they're interested in rebuilding. And these were due to fire, of course. And they're interested in rebuilding using mass timber products for the affordable housing aspects of these small towns. So prices are coming down rapidly. The cost of wood has shot up worldwide recently. That's making it a bit more challenging. But again, based on the fires, the flooding, the hurricanes, I don't think we have any choice. So I think we need to all stop basing all decisions on price when the price of our world burning is far outweighing these minor cost considerations. I think we need to convince development teams that yes, it may be a little more expensive, although we're seeing equal or better. Even if it is a little more expensive, we need to make that choice for the betterment of our cities. So And sorry, I think you asked about walls. We don't do cross-laminated timber walls, so we're still standard stud framing walls, whether that's steel or wood.
Great, thank you. We have time for probably one more question. So a lot of questions we get are around issues of fire safety, issues of acoustics and vibration. Julian, you mentioned in your two different projects, you had two different approaches to fire, one with the gyp cladding on the wood members and one without. Do you want to maybe speak to that a bit?
Yeah, at 55 South Bank Boulevard, we couldn't expose the timber because we would have needed to add a charring layer to that timber to allow it to burn before the kind of core timber structure was affected. So that would have led to much thicker cross-laminated timber walls than we've actually ended up going for, which would have led to too much additional weight for the existing structure. Hence our decision to minimise the thickness of the cross-laminated timber, even to the point of reducing it on the upper levels and cladding it in double layers of fire check or drywall. And then if we compare that to our project at 25 King Street, what we did there was we actually added a charring layer. So there's the structurally performing Glulam columns, and then there was an additional 63, actually an additional 70 millimeters on average of additional timber added to those columns to contribute or to allow for that timber to burn for the 2 hours, or it's either 2 hours or 90 minutes. I can't recall, but it was a period of time when that timber would burn, because we know that the timber burns at a rate of about 0.7 millimeters per minute. So two quite different approaches. I mean, ideally, you would say that you would always, as Ben's alluded to, prefer to have the timber exposed. And look, unfortunately, in Australia, we are seeing our fire brigade, who are an approval authority in Australia, pushing these sorts of buildings now towards cladding, particularly soffits, timber soffits with fire check or drywall or plasterboard, unfortunately. So it's an ongoing debate in Australia at the moment.
Great, thank you. So with that, we are right at the end of our allotted time. Thank you, Julian and Ben, for your presentations and your expertise. That was really wonderful. And for those of you that we didn't get to your questions, we'll ask Ben and Julian to answer those later on, and we'll post that on the CarbonPositive website. We're going to take a 1 hour break now, in which we'll have 2 30-minute tool tutorials. And then after that, we'll have 3 more rounds of sessions. So we look forward to seeing you in future sessions. Thank you both.
Thank you, Lindsay. Thanks, Julian. Have a nice afternoon.
You too.
Nice morning.
Bye.